everybody, it's Mrs. Pound, and I am back with some more about atomic structure in chapter 1.3. And today we're going to take a look at the structure of the atom according to the most current atomic model. We took a look at the history of atomic models in the last video, and this time we're going to take a closer look at the most current models. So our objectives today are to determine the number of particles in a neutral atom using the atomic number and mass number, and to identify particles in isotopes and calculate the atomic weight. So in order to better understand atoms, we have to get some vocabulary out of the way. So the nucleus of an atom is the center of an atom that contains protons and neutrons and is surrounded by an electron cloud. It's the same word we use as for the nucleus of a cell. Nucleus just meaning that middle part. And if you can see in the background there, the nucleus are the orange and blue balls. And those in this model in the background. And those are the protons and the neutrons. And the electrons are whirring around on these orbitals, and there are these little dots here. Now, a neutron is a subatomic particle that has no charge in the nucleus of an atom. Absolutely no charge. And so that's why it was the last particle to be discovered of the ones that we're talking about. The proton is a positively charged subatomic particle in the nucleus of every atom. And the atomic number, when we take a look at that, that is the number of protons in an atom of an element. So atomic number equals the number of protons. The mass number is the sum of the number of protons and neutrons in an atom's nucleus. So we add the number of protons to the number of neutrons to get the mass number, where the atomic number is only the number of protons. And the atomic number also determines what the element is. Now, we have to be careful with isotopes. This is where John Dalton, after more research, he was proved wrong on the atomic mass being the different elements, where now we understand it to be the atomic number. An isotope is an atom of an element that has the same atomic number, but a different number of neutrons and a different mass number. So elements all have the same number of protons, so isotopes all have the same number of protons, but they have different number of neutrons, and so that changes the mass. So not all atoms of an element necessarily have the same mass. It depends on how many neutrons they have. The atomic weight, and we have to be careful between mass number and weight. The atomic weight is the weighted average mass of the isotopes of an element. It is not a whole number, as we are going to see when I show you these numbers, because it is a weighted average, and most elements have one or more isotopes. So, for instance, let's say there are two isotopes of an element, and 80% has a mass of, say, 16, and 20% has a mass of 17. And so what they do is they multiply the 16 times 0.8, they multiply the 17 times 0.2, they add those together for the average, and so that's why they are not whole numbers. Now, the other particle in an atom is the electron, and it is a negatively charged subatomic particle outside of the nucleus of an atom. And in our model, these are these dots on the orbitals. In a neutral atom, we know that the number of protons equals the number of electrons. So the number of electrons in a neutral atom, not a charged atom, in a neutral atom is the same as the atomic number. And the other thing we have to know about electrons is that the most stable electrons with the least amount of energy are located in the energy levels closest to the nucleus. It's a lot like the rungs on a ladder. As you climb up a ladder, it becomes a little more wobbly as you go up and a little more unstable, and you're more likely to fall, right? Well, it's the same way with an atom. The closer you are to what we call ground state, the ground, the more stable you are. So even on a ladder, the closer you are to the ground, the more stable you are. As you climb the ladder, you can feel that it becomes less stable. Okay, and that's also the way the stability, of electrons works as well. Now I'm going to switch over my camera and we are going to look at some models of atoms, and we're also going to look at sample squares on some periodic tables, because we are going to be talking about periodic table in the next video, to show you how to apply these vocabulary terms to what we have just been learning. So have out your extra sheet that I gave you that goes along with these notes. Okay, so here we are on the extra sheets that go with this section, and I first want to look at this. This is a square from a periodic table, and what we see up in the left-hand corner is the atomic number. Remember, this is the number of protons in one atom of an element. We also have the symbol, and it says here that it's derived from the English or Latin name and is 1 or 2 letters long. That's why some symbols don't match up with the name very well, because they're using the Latin name to get the symbol. And notice the first letter is always capitalized if there are 2, and the second letter is always lowercase. We also have the atomic mass, and notice we said that this is not a whole number because it's the weighted average mass of the isotopes in an element. And then the name at the bottom. So going down here, we have a model of an atom. We have in the nucleus, okay, so this is the nucleus. We have the protons and the neutrons. And this just happens to have 3 protons because lithium up here has the atomic number 3, so it has 3 protons. And it has 7 neutrons. To get the mass number, we can round 6.9 off to 7, and that helps us to get our neutrons. And the mass number is the total number of protons and neutrons in an atom's nucleus. Now, just so you can tell, this is the symbol P+. Protons are positive. Neutrons, I'm just going to write a 0 in parentheses. This means that it has no charge. And neutrons, the symbol, it's hard to see here, is N with a 0 for no charge. So to get the mass number, we add up the 3 protons and the 4 neutrons, and we get 7. So we could also write this as lithium 7 with the mass number. Okay, and also we'll notice that out here are the electrons. Notice that there are 3. There are 3 protons, there are 3 electrons in a neutral atom. So let's go to the back side here. And I want to focus first on that square from the periodic table. And again, here, this is a little bit different than the other one. Sometimes they look different, but here is the atomic number, which is the number of protons. So number of protons equals the atomic number, which in this case is 1. We have our atomic mass. Notice it's not a whole number because it's an average. We have the symbol for hydrogen, which is just H, and its name, hydrogen. Now, how would we find the number of neutrons? That is the atomic mass, rounded off, minus the atomic number. And so in this case, it's 1 minus 1, so it is 0. There are 0 neutrons for hydrogen. And then the number of electrons equals the number of protons, so that is 1. Okay? Now we go over here and we just have a model of an atom. So we have to figure out, what is this atom? How many protons does it have? How many electrons? So I'm going to put protons over here, neutrons, and electrons. So we have to figure out. Now, a number of electrons is easy. We could just count them up, right? So let's go ahead and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons. Now, protons and neutrons are here in the middle, but it's kind of hard to see exactly how many they have in here because they have some inside that are hiding. But we know that the number of electrons is the same as the number of protons in a neutral atom. So we'll just write 11 for that. And so that is now enough information for us to look on our periodic table and find that, okay, number of protons is the atomic number, here 11, so that's sodium. So here I have sodium. And now I want to find the number of neutrons, so I look back here, I see 22.99. So I know that's a little blurry, but you have a periodic table you can look on. So I round that off to 23 because this is the atomic mass rounded off. No. Atomic mass rounded to get the mass number. And I subtract 11 from that and I get 12 neutrons because I subtracted the number of protons because remember the mass number is the number of neutrons plus the number of protons. Okay, some other notation you might see is this O16. This is more your isotope notation. This here is the mass number because it's telling us the isotope. We see O is oxygen, so we know we have oxygen. Our atomic number. This notation does not tell us the atomic number, so we have to go to our periodic table, find oxygen right here, and it has an atomic number of 8. So if we know the atomic number, we know the number of protons is 8. Now the number of neutrons, they gave us the mass number 16. We subtract the atomic number and we get 8. And then the electrons is the same as the number of protons, so it is 8. So that's how we use that. Now there's also this type of notation that we'll see. W is tungsten. One of those weird ones. It must be from the Latin name. I don't know the Latin name, though, to tell you. In this type of notation, we have the mass number. The mass number is always larger because it's the protons plus the neutrons. We have the atomic number. So our number of protons is the same as the atomic number, 74. Our neutrons, we subtract the atomic number from the mass number, so it's 184 minus 74 equals 110. And our number of electrons will be 74 because it's the same as the number of protons in a neutral atom because they have to balance out for there to be no charge on the atom. Because remember, protons have a positive charge, electrons have a negative charge, and neutrons are neutral, so they have no charge. So that is some notation and models and periodic table squares. You can refer back to this when we're looking at these different things in class. Okay, so our objectives today were to determine the number of particles in a neutral atom using the atomic number and mass number, and to identify particles and isotopes and calculate the atomic weight. Now, the calculate the atomic weight thing, we're going to do that at another time. So remember your 5 questions, and I'll see you in the next video.